Hello friends, in this video we will see how the pressure is varying in a fluid at rest. So for the explanation point of view, I have taken one fluid element inside the fluid. This is the free surface of the liquid and these are the coordinates of the fluid elements. Delta A, this is the cross-sectional area of the fluid element. Z, this is the distance of the elements from the free surface of the liquid, and delta Z, this is the height of the fluid elements. So this fluid element is inside the fluid, so here some pressure force will work. So first of all we should know what should be the pressure intensity on the face AB and CD. So now suppose P, this is a pressure is working on the face AB, and the pressure on the CD, but obviously it should be high in comparison to this P. So now here we will see what the intensity of the pressure on the CD. So the intensity of the pressure CD would be P plus the intensity of the pressure on the face CD, that would be P plus dou P upon dou Z into delta Z. This dou P upon dou Z plus delta Z, this is nothing but this is a change in pressure vertically direction. Now we have to find out how much pressure force is applied on the face AB and CD. So the pressure force on the AB, this is equal to P into delta A. Delta A is the cross-sectional area of the fluid element, and same pressure force on the CD. So P plus dou P upon dou Z into delta Z into delta A. Suppose we want to calculate the pressure at any point inside the fluid, then the hydrostatics law come into picture. Hydrostatics law says the rate of increase of pressure in vertically direction, it should be equal to the specific weight of that fluid at that point. So with this law, we will find out what would be the pressure at any point inside the fluid. So now we have to find out the weight of that fluid. So the weight of the fluid element is nothing but this is a density into G into volume. Density we know rho, G we know, and the volume is delta A into delta Z. So we have written the volume here. Now we will balance the forces at any point. So as per the hydrostatics law, the rate of increase of pressure, it would be equal to the specific weight of the fluid element. So P into delta A minus P plus dou P upon dou Z into delta Z into dA, that is equal to, this is the weight of the element. So now I'll solve this expression. So P into delta A minus P into delta is same, so both are cancel out. So the rest part of the expression is minus dou P upon dou Z into delta Z into delta A plus rho into G into delta A into delta Z, that is equal to 0. So now if I'll again rearrange, and whatever be the common terms we have, I'll just cancel out. So the rest part of the equation is del P upon del Z is equal to rho G, and this rho G is nothing but this is a W. W is nothing but this is the weight density of fluid. So now again we'll remodify dP upon dZ, because we are checking the effects only in vertically direction. So partial derivative change into this total derivative. So dP upon dZ is equal to W. So this is nothing but this is your hydrostatics law. So from this expressions we can see the change in pressure in vertical direction, that should be equal to weight density of the fluid, or we'll say the specific weight. Now if we'll take the condition, suppose the flowing fluid is a liquid, then in this case we can simply integrate this expression. So this dP is equal to rho G dZ, and from here we can find out the expression. This is P plus rho G into Z. Again I'll rearrange, so Z is equal to P upon rho G. So this P upon rho into G is nothing but this is a head. So with the help of hydrostatics law, we can find out the pressure at any point in the fluids when fluid is rests and no in motion. Thank you friends. I hope you will clear the law of hydrostatics. If you like it, then please share and subscribe with your friends.